Now, should be recording. Okay, we're gonna have to look at it another time, sir. Okay, so this is the last example problem, practice problem from 2.2. This is the difference quotient. Anybody remember what the difference quotient said? F of x plus h minus f of x over h, right? So that's the difference quotient. So that might be a good idea of putting that on your cheat sheet, which Teddy's not here to hear me mention the cheat sheet again. But anyway, h can't be 0, correct? Because that would be dividing by 0. Okay. So I'm going to take my f of x, which is 5x minus x squared, and plug in x of h, and then I'm going to plug in x, then I'll simplify that. And if all goes well, the h from the bottom will, in fact, be canceled. Okay. If it doesn't cancel, you probably did something wrong. Probably a sign change or something going on there. So I'm going to take 5 times x plus h minus, in parentheses, x plus h squared. So there is my f of x plus h minus, and I'm going to say this again, I'm subtracting the entire function f of x, so put it in parentheses. So minus, in parentheses, 5x minus x squared. Close parentheses, all over h. Next step, we'll multiply everything out. So in the first piece, I'm going to distribute the 5. That gives me 5x plus 5h. And remember, when you have a negative sign in front of of something that's being squared, do the squaring first, and then we'll distribute the negative sign. So I'm going to keep this negative sign for now. X plus h squared. First times first is x squared. Outside times outside would be xh. Inside times inside would also be xh. xh plus xh is plus 2xh plus h squared. I'll go ahead and distribute the next negative sign. It gives me negative 5x plus x squared all over h. Next step, I'll go ahead and distribute that negative sign. Now, actually, would y'all be okay if I just worked it from here and combine like terms from here? Can y'all follow that? So let's look at our x squared. If you notice right here, I have a negative x squared, and over here I have a positive x squared. So it's going to cancel. Right here I have a positive 5x. Here I have a negative 5x. So they cancel. Is there any other term that's going to cancel? Nothing else will cancel. Okay. And every term in the numerator now has an h in it, which is a good thing because it's going to cancel. Okay. So on the top, I have 5h. Distributing this negative sign gives me minus 2h minus h squared all over h. Factoring an h out of the top. Nice. There we go. Gives me h times 5 minus 2x minus h over h. The h cancels. And my final answer is 5 minus 2x minus h. And I don't know if there's a proper form of writing that or not. You know, do we write the 2x first because it's the negative 2x first? I don't know. And I also don't know about the homework, how it's going to accept it. I don't think it really matters. Any questions on that? Right. So there you go, sir. No problem. All right. And that wraps it up for 2.2. And we're jumping right into 3.1. So now we're looking at quadratic functions and quadratic models. So quadratics means we're dealing with functions that have x squared in it. So we're going to analyze these functions. We're going to write the quadratic function in standard form. We're going to sketch them, find maximums and minimums. And that's what's going on in 3.1. So we're going to study the graphs of polynomial functions. We've been introduced to f of x equals ax plus b. You're familiar with y equals mx plus b, right? Y equals mx plus b is going to be your basic linear function. F of x equals c. Well, c is not a variable. C is just a constant. So it's just a horizontal line. And here we have f of x equals x squared. This is called the scoring function, and the scoring function is a quadratic. All of those are polynomials. The graph of a quadratic. Let's talk about just a polynomial function in general. This is the general form of any polynomial function. It's going to have some coefficient times x raised to some power. And if it's in general form, that power should be the highest power. Okay. Plus some other coefficient times x to the one lower power, one lower power, one lower power, until we get to our constant. Remember that when it's in general form, the highest exponent is first, right? The coefficient in front of the first term is called the leading coefficient. And the highest degree, or the highest exponent, is going to be called the degree of the polynomial. That's just to indicate that these are all not necessarily the same number. Okay. If I just had a in front of every one of them, then a is a is a is a, right? Whereas a sub n could be 12. It's possible that a sub n minus 1 is also 12, but it doesn't have to be. It could be 13. So it's just to differentiate. And the exponents are just descending. So yeah. Any other questions? Okay. 1 second. Make sure. Yeah. The graph of a quadratic function. Each of the following is a quadratic function. They're all quadratics because they're degree 2. Some of them might not be as obvious as others. Some of them aren't written in general form. This is written in general form. This one's written in what's called vertex form. Go ahead and give it a name here. Because as you're doing your homework, if it says to give the answer in a specific form and you give it in the wrong form, it's going to be wrong, right? So that's general form. This one's called vertex form. And we've done this before. So that said, can anybody tell me the vertex of g of x? Where is the vertex of this quadratic? Anybody know? -1, -3. The vertex is at -1, -3. Okay, we're going to talk about all that again. Letter H, it is a quadratic because the highest exponent is 2, but it's not in general form because the x squared is the last term instead of the first term. K of x, this is actually in general form as well. It's just there. There's not a form there. No. General form means your exponents are going to be decreasing. If a homework question or a test question asks you to write the answer in general form, if you wrote it like H, you just got it wrong. If you'd have written this as 1/4 x squared plus 9, that's general form, descending powers. Now it's right. They actually call this standard form as well. Okay. I've seen vertex form also called standard form. Yeah. What's the last one? Can you tell that that's a quadratic? You would have to FOIL it, right? And the highest degree would be x times x, which is x squared. Okay. This would be factored form. That's a quadratic. It has no name. This is the, I wrote it this way and it asked for general form, so I got it wrong. Okay, that's what that is. The graph of a quadratic function, a can't be 0. So we've got the quadratic function written there in general form. Why can a not be 0? the quadratic. Yeah. If a was 0, ax squared would be gone. And what would be left? And what would bx plus c look like? A line. It'd be a line, right? We just changed the letters. Instead of mx plus b or ax plus b, we have different letters. It's just gonna be a line, okay? The graph of a quadratic looks like a U. It's called a parabola. Moving on. Parabolas are symmetric, right? We have a line of symmetry. The line of symmetry is going to be a vertical line that separates the parabola into two halves. And what point is on the axis of symmetry? That point is called the vertex, okay? The only point on the axis of symmetry is called the vertex. And the vertex can be either the minimum value if the parabola opens up, or maximum value if the parabola opens down. How do you know if it's opening down? Well, the leading coefficient is negative. That makes it open down. And again, a lot of this, folks, should be reviewed. I just talked about this. When the leading coefficient is positive, the graph opens up. When the leading coefficient is negative, the graph opens down. The most simple type of quadratic is going to be simply ax squared. What is the parent quadratic function? The x squared, right? Y equals x squared, f of x equals x squared. You cannot get any simpler than that. Okay, a is going to change the direction of opening. Do you remember what else a will do? Down. What else can a do? Yeah, it can make it fat like me, right? Or skinny, like not me. Okay, I'm recording. I'm not going to throw anybody under the bus other than myself. Yeah. Well, it just it kind of messed up on me during calculus yesterday. It didn't record the last 3 minutes, and I used this to record one of my night class lessons, and it sounded really well. By the way, when I'm recording my night classes, I'm kind of behind y'all right now, but I'm going to eventually catch up and probably pass y'all. I am posting the recordings that I'm doing from my night class in the classroom. You might have saw it last night. Like yesterday, I recorded P3, I think it was. But anyway, those will be there. Okay, we talked about all this. I'm trying. Okay. So when you're sketching the graph of y equals ax squared, you want to start with y equals x squared. Do y'all remember us doing that? We would graph the parent function, and from the parent function, we would talk about the transformations. It moved left, it moved right, it moved up, it moved down. It's skinny, it's fat, it opened down, it opened up. Okay, so that's what this is talking about. So the difference between y equals x squared and y equals 1/3 x squared. What does the 1/3 do? Wider, okay? So remember, the closer to 0 it is, the wider it is, all right? And so you can see in this graph on the right side here, the light parabola is going to be your y equals x squared, and the dark one is going to be your 1/3 x squared. Okay. What's part B going to look like? 2x squared. Okay, it's going to be steeper, right? The vertex is still going to stay at 0, 0. It's just going to go up a lot faster. Okay. And that's going to be shown on the next graph. And there's a comparison of the two. So we use the term stretch to compress. I talked about gummy bears. You know, if you take a gummy bear and stretch it, it gets skinnier. If you squeeze the gummy bear head to toe, it gets wider. So that would be a compression and a stretch. So 1/3 would be a compression, vertical compression. 2 would be a vertical stretch. Okay. In example 1, if the coefficient determines how wide the parabola is, and this is talking about the fact that when the absolute value of a is small, it's wider than when the absolute value of a is large. Do y'all understand why they're saying absolute value? You know, because technically, -1/3 is larger than -4, right? So you can't say when a is larger than another one, then it's going to be, you know, whatever, wider or slimmer. So if you take the absolute value, then obviously the absolute value of -4 is larger than the absolute value of -1/3. And as soon as we throw a negative in there, that negative is going to cause the parabola to open down. The first example shown there is the graph of -x² + 1. So the negative made it open down, and the +1 caused the whole function to increase by 1. And so we have a vertical shift up 1 unit. And the next example, a is just 1. We have a horizontal shift to the left. And remember, the vertex form was g of x equals x minus h squared plus k. And so that's just a reminder of, when I'm looking at x plus 2 and I ask, well, what's h? Well, h is not 2, is it? H is -2, because x minus -2 would make it look like plus. So that's why when h was -2, it went to the left. But I like thinking of it as it's in a grouping symbol. It's going to be backwards from expected. Okay. Yeah, exactly. When it's inside. On the outside, that's a -3. What's that mean? Down 3. Okay, so standard form of a quadratic. Standard and general are different. Okay, general is the descending powers. Standard form is also what I call vertex form. The text more often is going to use standard form than vertex form. Okay. By writing a quadratic in standard form, you can find the vertex easily because the vertex is located at the point HK. All right. To graph a parabola, a lot of times it's easier to go ahead and write it in standard form by a process called completing the square. Because once you complete the square, that puts it into standard form or vertex form. And we're going to look at completing the square just a little bit. How do you find x-intercepts? To find the x-intercept, y equals 0, right? So if you set y equal to 0, you can do things like the quadratic formula, factoring, completing the square, so many different ways of finding the x-intercepts. When does a quadratic work when trying to find solutions to a quadratic? When does the quadratic formula work? When can you use the quadratic formula to solve a quadratic? Always. Okay. I guarantee you, if you do the math right, the quadratic formula always works. Does everything factor? Not everything factors, right? And completing the square is difficult. Okay. Quadratic formula always works. What happens when a parabola does not have any x-intercepts? No real solutions. It's got imaginary solutions, right? All right. So if we had the original function 2x² plus 8x plus 7, and we were to write that in standard form, to write this in standard form, the process they'd go through is a little bit different from how I've taught you in the past. I'm not going to represent to you what I've done in the past. If you need to stand, stand. If you want to, if you want me to go over the putting it into standard form the way I've done it in the past during tutorial times, look at your notes otherwise. I'm going to walk through what they've done, and it's very similar. So in order to complete the square, remember, a has to be 1. Well, the problem they gave me, a is not 1, is it? So to complete the square, I'm going to complete the square on the 2x² plus 8x. I'm going to ignore the 7 for now. Okay. So to complete the square, what I have to first do is factor out the 2. We're not looking for a greatest common factor. It's got to stay a quadratic. If you factor out the x, it's not a quadratic as per se anymore. It is, but it wouldn't look like one. So if I factor out a 2, my a is now 1. Okay. At this point here, we're about to put some more information after that 4x. But right now, all they've done is factored out the 2. All right, next step. Y'all ready? You good? Okay. After the 2 has been factored out, I look at that 4x. Half of 4 is 2, right? Half of 4 squared is 4. So what they're doing is they are adding and subtracting within the parentheses. That's not how I did it. Y'all remember that? Remember, I would add and then subtract, but I would subtract on the outside. Okay, they're doing it on the inside. And that's okay. What they've done here now is they have made that is a perfect square. They're not going to do 4 minus 4 because they put that 4 there for a reason. By adding 4 minus 4, did they change anything? What's 4 minus 4? So they've done nothing, okay? And that's what they had to do. Because they added the 4, they had to subtract the 4. Now what they've done is they said, okay, well, I'm going to break that up into 2 pieces. I know that the 2 is going to be multiplied by my quadratic, but that 2 is also going to be multiplied by the negative 4. So they regrouped the terms to make it easier. All right. Now what? You don't want to distribute. Not right now. What do we want to do? We made a perfect square. What do we do to this perfect square? Factor it. Okay, we're going to factor that perfect square. What does x squared plus 4x plus 4 factor into? X plus 2 and x plus 2, right? Okay. So because it factors into x plus 2 times x plus 2, that's the same thing as saying x plus 2 squared. That negative 8, that was the negative 2 times 4, right? And there's a 7 that was there, so it's now in standard form. Now that it's written in standard form, I can look at it and say, okay, the vertex is at negative 2, negative 1. Plot the point negative 2, negative 1, plot some more points. That 2 caused a vertical stretch, so it's a little bit skinnier than the parent function. Notice that they didn't graph the parent function to begin with. They actually graphed y equals 2x squared. So once you take the graph of y equals 2x squared, you can take all the points, move them to the left and 1 down, and there you go. Sure. Right there. Good. Okay. Okay, this 2 is what went right there, not that one. Because remember, this is supposed to be x minus h. That's why it's negative 2. Okay. Yes. Other questions? Okay. Okay, and looking at this figure, it talks about it. Notice there's a dotted line here, a vertical dotted line at x equals negative 2. Why is that there? That's the axis of symmetry, and that's what this next slide says. In the figure, you can see the axis of the parabola is the vertical line through the vertex, which is at x equals negative 2. So how do you go about finding the minimum and the maximum? Well, to find the minimum and the maximum, we're going to find, you're going to complete the square, write it in standard form. This is what standard form is going to be. This is a general, simple standard form, though it's very ugly. This is how you find the vertex. Do y'all remember that formula? Negative b over 2a. What's that tell you? Axis of symmetry. X equals negative b over 2a. So negative b over 2a is going to be the x value of the vertex. X equals negative b over 2a is the axis of symmetry. Negative b over 2a is what you plug into the function to get the corresponding y value of the vertex. Does that make sense? So look at your quadratic. Calculate negative b over 2a. I like writing it with a negative on top with the b, kind of like the quadratic formula, because that's where we put it in the quadratic formula, right? So calculate negative b over 2a, get that value, whatever it is, plug it into your function, and that will give you the vertex. Okay. If a is positive, it's opening up. So the vertex is going to be a minimum. If a is negative, it's opening down. So the vertex is going to be maximum. Okay. The maximum height of a baseball. The path of a baseball after being hit is given by the function f of x equals negative 0.0032x squared plus x plus 3. X is the height of the baseball in feet. X is the horizontal distance from home plate. What's the maximum height? What's this parabola look like? Opening down. Pretty flat too, isn't it? Okay. Does that make sense for the path of a baseball? Okay. I want to know how high that baseball went. So let's find the axis of symmetry. That formula is x equals negative b over 2a. I'm going to trust y'all with calculators to give me the correct answers on this. Negative b would be negative 1 over 2 times negative 0.0032. $156.25. Okay. What does that mean? What does that 156.25 tell us? I hit the ball. The ball traveled. Yeah, it's going up and then down. After it, 156.25 feet, after it's left the plate, it's at the highest point. What's it going to do after it hits the highest point? Start coming down, right? Okay. So all I know right now is I know the distance from home plate to get the highest height. Is that what the question asks for? What's the question want? What is the highest? Okay, which means what is f of 156.25? Which means we're just going to take that function and plug it in. And give me a couple answers after you plugged it in. $81. 81.125. 81.125. Okay. Does it make sense that the ball went further than it went up? All right, that'd be a good thing, right? Okay. So what is the maximum height of the baseball? The maximum height of the baseball is about 81 feet. Would that be an acceptable answer? Now, I don't know how it wants me to round it. It didn't say. But that's the height. And I found the height of the ball by calculating the vertex. Questions on that? And I'm sure the next slide has it worked out. So let's see if they agree with us. Solution, they wrote the equation. They figured out what A, B, didn't need C, but they plugged it into the formula, x equals negative b over 2a. Moving on. 156.25 feet, got that answer, plugged it in, 81.25 feet. The only thing I did not write down was the units. Okay. All right, guys, we're gonna go ahead and stop there. Tomorrow, we're gonna have to get going, okay? If you haven't started working on your homework, that's not good.